Let's try some examples. So, given each right triangle, find the sine, cosine, and tangent of each acute angle. So the first thing I'm going to do here is write down SOHCAHTOA because I know that that will be helpful to me. So SOHCAHTOA. Okay, so I know that the sine of an acute angle in a right triangle is the length of the opposite side over the length of the hypotenuse. Cosine is going to be the length of the adjacent side over the length of the hypotenuse, and tangent is going to be the length of the opposite side over the length of the adjacent side. So it said of each acute angle. So we've got two acute angles here. We've got D and we've got F. So let's just start alphabetically, but it doesn't really matter. You could do either one first. So let's start with the sine of angle D. So again, we write sine D, and then we know that it's just going to be the length of the side opposite angle D, which in this case is 4, so 4, over the length of the hypotenuse, which is the side opposite the 90-degree angle. It's also the longest side in the right triangle, so that's 4 over 5. Okay, the cosine of angle D is just going to be the adjacent over the hypotenuse. So again, two sides form angle D here. One of them's hypotenuse, 5, and the other is the adjacent, 3. So it's just going to be 3 over 5. And then we've got the tangent of angle D, which is just the opposite over the adjacent. So opposite was 4, and the adjacent was 3. Perfect. Now let's do the other angle. So we'll do angle F. So the sine of angle F is just going to be opposite over hypotenuse. So opposite is 3. So 3 over the hypotenuse, which was 5. And then the cosine of angle F is just going to be the adjacent, which is 4, over the hypotenuse, which is 5. And then the tangent of angle F is just opposite over adjacent. So opposite is 3, adjacent is 4. And then remember I told you can notice the things that are the same. So 3/5 for sine F, 3/5 for cosine D, 4/5, 4/5, and then 4 over 3, 3 over 4. So you probably did it correctly. So good job. So I have another one down below. So let's check that one out. This one's a little bit more difficult. All right. So again, because we can't see the SOHCAHTOA anymore, I'd write it out one more time. I mean, there's no harm in doing it. And I noticed when I told my students that it was a requirement, I made it worth a point on their test to actually write it out. More students got the problems correct. So I just think there's no reason not to. Don't try to be a hero, just write it out. It's very helpful. Okay, so again, the acute angles. So my two acute angles are angle G and angle H. So let's start with G. So the sine of angle G is just going to be, remember, sine is opposite over hypotenuse. So the opposite is 4 over the hypotenuse, which is 8. Now, here's the question. That can be reduced. So you want to check with your teacher about what they specifically want. They may want you to leave it as 4 over 8, even though it's not reduced, because they might just want to see that you identify the size and they might not want you to spend too much time. I would reduce it because I think, technically that's the correct answer, is to reduce it. So it will be 1/2. Good. So now let's do the cosine of G. The cosine of G is the adjacent over the hypotenuse. So G adjacent is going to be 4√3 over the hypotenuse, which is 8. And this is going to reduce to, that goes to 1/2, so just √3 over 2. Perfect. And then the last one is the tangent. So the tangent of angle G is the opposite over the adjacent. So opposite is 4 over adjacent is 4√3. So the 4's divide out, which brings you to 1 over √3. Now, here's the problem. You can't have a radical in the denominator, so we need to get rid of that. So you just remember that if you multiply by root 3 over root 3 over root 3, you end up with 1 times root 3 being root 3, and then root 3 times root 3 is just 3. Boom. There you go. So remember, you have to make sure you don't have any radicals in the denominator. Okay, you have to rationalize the denominator. That may be what your teacher said. That's what I tell my students. No radicals in the denominator. That's illegal. Okay. So next up is our other acute angle, which is angle H. So the sine of angle H, again, it's just going to be the opposite over hypotenuse. So opposite is 4 root 3 over the hypotenuse, which is 8. So then this reduces to 1/2 root 3. So, or yeah, you know what? I'm going to do root 3 over 2. Okay, perfect. And then the cosine of angle H is going to be the adjacent side. Ooh, whoa, you get the point. Which is 4 over the hypotenuse, which is 8. So that reduces to 1/2. Perfect. And then the tangent of angle H is just opposite, boom, boom, which is 4 root 3 over the adjacent, which is 4. Oh, and this is nice. The 4's divide out, so we're just left with root 3, and then nothing's in the denominator, so that's great because we don't have to rationalize anything. So there you go.